The first part here is fine because you're using seconds. These units are miles per hour per second. You integrate it with respect to seconds. The thing to realize is if we want the velocity at 8, you can start with the velocity at 0 and then add on the net change from 0 to 8. This is the key to this section, is saying this is the net change from 0 to 8. The integral from 0 to 8 is how much the velocity changes. The net change in velocity is the integral of the rate of change of velocity, or acceleration, what you're given, from 0 to 8. We use an antiderivative like this and evaluate it, or you can use a calculator, of course. That gave us this specific thing. For this one, we actually need a function, and I think I got one step ahead of you here, or one step ahead of where I should have. If you want the function for velocity, we can do this exact same thing as we did up here, except we won't use 8. We'll use a variable, right? We'll use a t here because we want now down here we want v of t. So instead of this, we want from 0 to whatever it happens to be, right? Time. So what you're going to write here then, if you do this, do a different color. This is 5 because it's the velocity at 0, right? Or maybe at first we'll put in v at 0. Plus the integral from 0 to, now this is a variable, we're putting t in here. The problem with this is we can't use a t here because that's not our variable. This is our variable. We're putting a t there. The variable is the upper limit of integration. You need a dummy variable here. A dummy variable, you need a variable dummy. You need a dummy variable here. You can use u, you can use whatever, you could use x, but I don't want to confuse you. You could use some other variable, it's where the time goes, but just to emphasize that this is the variable in this function, right? It's a function of t. The variable is the upper limit you're going to here, the upper limit of integration. So you can use u du here. That's, what was the function called up above there? Acceleration at a of t. I'm calling it a of u now because I'm just using a different variable because I want the t to be right there. I want to make it clear that that's the variable. This is a dummy variable. Dummy variable. Dummy, you can spell it however you want. You know, like a crash test dummy? You know, like a crash test dummy, not like you dummy. Like you put a crash test dummy in a car because you're putting it in place of a real person, you know? To use in place of a real person, taking their place for now. This is what we're doing, right? It's kind of like a placeholder there. What? Now, this function that you have here, nothing was wrong about what we're doing, except that what we should have done here is we should have just used 8, and then in the end converted the units. Okay? Convert after the original function, because if I start converting the times beforehand, the fact that you're raising it to the power of 3, like we convert it beforehand, but then we're over-exaggerating that conversion because it gets raised to the power of 3. What we should have done is kept the thing in the units that you're given, and you'll get some weird units here as an answer that you will have to convert after. We started with miles per hour per second. We integrated it with respect to seconds, so we got this and that canceled. And then if you integrate it again with respect to seconds, you get miles per hour times seconds. But you can convert those because you're good at unit conversions, right? Miles per hour times seconds, you can convert those after. Yeah, miles over hours, miles per hour times seconds. But we want it should be just a distance, right? It should be just end up being a distance. So what you can do is convert. You can convert the times 1 over 3600, right? Because that's what we did up above. But we did it beforehand, and then we raised it to the third power. That's where the error was. Okay? At the end, we're going to do that. Otherwise, we over-exaggerate this conversion here. So I'm going to erase all this. And hopefully by then, some of you have settled down finally. If you integrate this function here, so I probably should fill in that this was 5 plus the integral from 0 to t of au, that thing, right? Oops, au, du. If you want to integrate that, oops, this was the integral from 0 to, this is interesting here because this was, oh, I was going to fill that in, wasn't I? 2.4. 2.4, sorry, 2.4 u du. I'm using a u in place of the t just because, again, we don't want to put the t in there yet. It's too dangerous right now to put the t in there. It's the dummy variable, just standing in place of the t right now. This is our velocity function here, right? That's the velocity function. You can write a function with integral notation in it. That's something new, right? Just like when you first learned about sine function, cosine, all that stuff, and then much later on, like you learned how to do sine of 30 degrees and evaluate all that. Then later on, you learned you could put it in a function, right? You could do function of x, add 3, 2. You could do that. You can do that. No. You can put this kind of syntax or this kind of that function, that integral function, in another function. You can write a function that has this as an operation in it, more or less. It has a variable here. It has a variable there. Okay? The integral from there to there, if you worked it out, it would be this, right? What would it be? If we evaluated this thing, from 0 to t, you'd get 5 plus... 5 plus, what is this? 2.4, isn't it? To evaluate this integral, you use... No, you use 1.2, don't you? In antiderivative of this? Times u squared. Evaluate it from t to 0 here, right? What does that give you? V of t. Well, if I put the t in there now, right, I'm substituting it in, right? Substitute a t in, then substitute a 0 in, what do I get? 5 plus, well, no, I'm not actually putting a number in there, right? Mr. B, are you solving part A or part B? I'm solving part B. A was fine the way it was. 5 plus, it's a function, right? Put the t in, you get 1.2 times t squared. If I put the u in, what do I get here? Like, I'm still looking at evaluating this. If I put the 0 in, what do I have? I have minus 0, right? So I'm not even going to put that. I'm going to just leave it like this. This is the velocity function. That's what we did last time, but I just kind of skipped over that and said, oh, here, this, by the way, that's the function. Really, you should be getting it by writing an integral like that and saying it's where you were at 0 plus however much it changes from 0 up to time t, right? It is the integral there, 1.2 t squared, plus the initial, which is 5. That's the velocity function. It is still a function where the units are the way they were at the beginning. So if we want now the position, okay, we want how far did it travel during those 8 seconds. We want the integral of that function, because that's the rate of change of the position, right? This is rate of change of position, right? And you want now, if you want the net change in position, net change in position from 0 to 8 seconds. You do integral 0 to 8 of that, okay? Of this function that we just came up with for velocity. That whole thing. Well, not the v of t. Well, we could put this in here, right? V of t dt. Or in other words, it's integral from 0 to 8 of that function. 5 plus 1.2 t squared. Can I put this down here, please? Because over on the margin there is not the greatest place. As a matter of fact, let's just go all the way down here. 10 minutes of complete disaster video. Okay, we're putting this down here, and then we are going to say to be continued in the next exciting installment of Calculus in the Afternoon.